What's up, everybody? This is me, Yawar Manzoor, and I believe everybody is doing great. Okay. Okay. I just need to know if I am live right now. Yes, we are live finally. Okay. That's great. One second, I need to check the settings. Yeah. So what's up, everybody? This is me, Yawar Manzoor, and I believe everybody is doing great, nice, and absolutely fine. Okay. And I just want to know in the live chat how many of you are feeling exactly great today. Okay. And today we will be basically talking about this electric flux in detail, whatever it is. Okay. Everything. And we'll be talking about the Gauss law as well. Understand what that exactly is. Everything we'll be talking about. Understand? And there are some questions also we'll be talking about. This is just the one shot of electric flux and the Gauss law. That's what we will be exactly dealing with by today itself. Okay? Yes. So before that, I need to know in the live chat if you can hear me and if you can see me properly. All of you in the live chat itself. Okay? Yo, that's great. That's great. So let's start. Let's get started and let's solve every damn question, whatever it is, by today itself. Okay, that's great. Now, ladies and gentlemen, boys and girls, this is a piece of information about me. My name is Yawar Manzoor and I'm a JEE Physics expert. Okay, I'm from Kashmir exactly. This is the experience that I have. And apart from this YouTube platform, we have our own platform. That's the Unacademy's platform, okay? Over here, we're teaching you completely free. And inside Unacademy, there are countries' top educators who are basically teaching you over there, who are giving you the next level content, okay? Quota's top educators are teaching you over there. And the most important thing is basically, in order to learn from those top educators which are inside Unacademy. And there are so many benefits that you will basically get if you go inside Unacademy, understand? So for that, you have to take this subscription plus or you have to take this iconic subscription. Now I'll explain that what are the features that you're gonna get in this plus subscription. You'll be getting live classes every single day, weekly tests, structured courses, unlimited access, okay? And in this iconic subscription, you'll be getting all the benefits you get in plus, and there are some extra benefits as well. That is this personal guidance, test analysis, experts guidelines, study material, study planners. Okay, now what does this personal guidance means? You will be given an educator who will be helping you throughout your exam till you crack your exam, understand? And this test analysis is once you are done with your test, afterwards you need to basically analyze what portion you are lagging in, so they will definitely help you in scoring good. Now if you want to follow me, you can definitely follow me on Unacademy. This is my username over there. Yes, and these are the batches which you can take this subscription for 3 months as well. Okay, there is some problem with my internet. One second, man. Yes, it is connected now. Okay, fine. So you can take it for 3 months and 6 months as well. Even there are EMI options available. You don't have to pay the entire amount at once. You can pay it every single month. Understand? Now for 3 months, the price is this one. Now if you want the maximum possible discount, so definitely you should go for this code. Use this code when you buy any of the subscriptions. It will definitely help you in boosting your rank, and it will definitely help you in basically getting the maximum possible discount. Same goes for this one. You can use my code in order to get this maximum possible discount over here as well. Now moving on to Iconic subscription. This you can take for 12 months, 18 months, 24 months. If you want the maximum possible discount, don't forget to use this code. Don't forget to use this code. Don't forget to use this code. So this is basically what? This is the price for 12 months, 18 months and 24 months accordingly. Now, what is in it for you? This is basically kickstart your JEE preparation 2022. Understand, you can get up to 100% scholarship for first 1000 rankers. Understand? So analyze your areas of improvement, structured academic plan. Understand? So this is basically, you should go for this one. This is a test. Understand? You should go for this test, and 1000 rankers will get free subscription. Understand? Is it lagging or everything is fine? I just need to know in the live chat. Is everything going great? Is it lagging? Okay. And now it will ask you for a code. Which code you should basically go for? You can use my code in order to enroll in this one. This is completely for free. Okay. Yawar. Okay. You can definitely enroll by using my code in order to get this one. Okay, okay, 1 second, there is some problem actually. What is that? I'm just checking it out. Okay, okay. Now is it fine? Yes, yes, that is in kinematics 2D, angular projectile. Okay. Okay, is it still lagging or this is fine now? Okay. So there is something big coming up for you if you're deciding for a drop. Understand? And we have this beautiful feature on Unacademy, that's ask a doubt. If you have any sort of doubt, okay, if you have any sort of doubt, there is this beautiful feature that's available on Unacademy. How you can exactly use this? If you have unlimited number of doubts, you can use this one. Understand? You can ask any doubt if you have. Ask the doubts any damn time. You'll be getting the solutions, that too in the video format with the high quality solutions and exact solution of that particular question. How you can exactly go for this, ask a doubt. What are the steps that you need to exactly follow? There is an option available in the app itself, that's doubts and solutions. If you take the plus subscription afterwards only. Okay. Okay. There are actually 2 more lectures in projectile motion. We are done with kinematics 1D, 2D, everything. Okay. Okay. So now see, so basically this ask a doubt. After that, you need to basically take a picture or you need to select it from that itself, from the phone itself, and that picture has to be basically clear. And after that, you need to crop that. You will get the solution within no time for sure. Okay. Now we need to basically start this one. I don't know what has happened to this one. Why is it lagging? 1 second. I just need to check. Okay. Just refresh once again. It won't lag now, I guess. Is it fine now? Is it fine now? One second. One second, one second. I'm just fixing it. We have the internet problem here, that's why. Okay, only audio is clear. Okay, I'm just restarting the session. I'm restarting the session. Now is it fine? Now is it fine? Restarted. One second. Is it fine now? I just need to know in the live chat if is it fine, if it is fine. One second, one second. Okay, that's great if it is better now. Is it better now? Okay, okay, once again. Sorry, guys. Shit, man. Is it fine now, guys? If not, then I'll have to end this stream and I'll have to reschedule this lecture. That's all I can do. Is it fine now? I just need to know in the live chat. Okay, fine. I guess so. Let's see if it works. Okay, so we need to basically talk about this electric flux, what this electric flux is all about. Understand? Now see, we represent this electric flux or this flux with phi. Understand? Now this is the electric flux, so we'll put over here, this is E. Understand? Electric flux E. If this was magnetic flux, then we can put that is phi and B over here, that is the magnetic flux. Okay, if everything is fine, I just need to know in the live chat if it is working properly now. Okay, fine. So before understanding this electric flux, let's just have a look on this area. Understand? We say area. Understand? So this is basically square over here or a rectangle. If I ask you, this is the length, this is the breadth. If I ask you to tell me the area of this rectangle, you will say, sir, the area of this rectangle is length into breadth. Or you'll say, this is A, that is A square is its area. Okay, fine. So till now, you were considering that the area of this or this area simply is a scalar quantity. Okay, fine. Now, today, from now onwards, you have to basically say that this area is a vector. See, if you have to basically show something is a vector, you have to show its magnitude and you have to show its direction. Understand? Now, if you say, sir, this area is a vector over here, so magnitude of this area is this a square. That's okay. Understand? Now, what is the direction of this area? If you are saying that this area is a vector, what will be the direction of this area? Can you basically say it like that? Yes. So, if I say, for example, this is a plane over here, so this will have some area. Understand? This will have some area. So, what is the direction of that? So, the direction of this area will be exactly perpendicular to this plane. Understand, this is the plane over here, so the area direction will be perpendicular to this plane. So we represent it with this one. So if I ask you how much is the area over here, you will say, sir, the area of this is S, or simply that is A. So what is the direction? You will say, sir, that is direction is this n cap. N cap is a unit vector in what? In this y direction, in upward direction over here, perpendicular to the plane. Now if I say area is this one, this is area, so what will be the direction of area? This outward. Or you can say the direction is also the downward over here. So direction can be inward, direction can be outward. This is the basically direction of area over here. Now the question is, if I ask you to tell me the direction of this one, you will say, sir, simply the direction of this one is basically this, in the outward direction, z direction, or in the inward direction, that is in the inward direction. So area will be how much? That is a square. And in the outward direction, how much exactly? So we say that is in that is k cap. Understand? Outward, and inward we say that is a square minus a square k cap. So from now onwards, if anybody asks you what is the direction of the area, you say him the direction of area is perpendicular to that plane. Understand? Perpendicular to that plane. So let's move forward. If I say this is the square over here, this square is having this length A, this breadth also A. Understand? This is basically side of square is over here A. If I ask you to tell me the area, you will say, sir, this area is very small. Understand? Side square, this length into breadth. Understand? That is A into A, that is A square. What is the direction in this case? See, this is in what? XY plane. So can I say direction will be somewhere along this one, that is K cap, or a direction will be somewhere along this one, that is a K cap minus K cap. Exactly. So what will be if I write the area of this is that is A square, and this will be, sorry, over here that is K cap, that is K cap. Understand? Outside or inside? Understanding this one? Come on, I just need to know. So I would definitely say this is nothing but that is K cap, or it will be A square minus A square, this K cap. Exactly. Fine. I hope you are understanding this one, what I am trying to say basically. Yes. Great. Now see, listen to me very carefully. Listen to me very carefully. Now the point over here is that if I say prove this, now see how you can exactly prove. We say this area is a vector. Understand? So it has to be, if I say this is length and this is breadth over here, you will simply say, sir, this is length vector cross this breadth, this vector. Understand? This side cross this side. So this is the cross product. Understand? Why cross product? Because we say this area will be nothing but that is A. What is length? That is A. A dot this A into A. What is the angle between this and this? We say A cross B. What is that? A, B sine of theta over here. Then it will be sine of 90 degrees. Angle between this length and this breadth is over here 90 degrees. So can we say in that case it will be nothing but A square. And in case of cross product, what is the direction of the resultant? The direction of resultant is clearly that is perpendicular to the plane of that L and B. So what is the plane of this L and B? This is L, this is B. So this is the plane. So direction will be along this K cap. So can I just write over here that it will be this K cap, or it will be in minus K cap. It will be in minus K cap. That is minus AK A square. Understand? Can you understand this one? Is it okay? Fine. Now, area vector as for 3D surfaces. So till now we were talking about the surfaces which were in 2D only. Understand? Two-dimensional surfaces. A sheet that we were talking about previously. Now if we have a surface something like this, okay, this surface. Okay, this is a three-dimensional surface. In that case, what will be the area vector in that case? What will be the area vector? You will simply say, in order to find the area vector of this one, simply I suggest you to take this very small element of this area, understand, which is having area of how much? That is a dA. For the entire surface over here, the area is A. For this very small element, the area is a dA. And what is the direction? That is normal to this one. Just draw it like this. Understand? So it will be dA exactly the area of this one, and this n cap will give you the direction of this area. Now, if you want to find the total area, integrate this one, you will find the total area. Understand? So this is basically the area vector. In simple words, what is this area vector all about? Area with a direction. If you have to represent the area vector of anything, you have to say how much is the magnitude of that area, understand, and how much is the direction. From where is exactly the direction as well as magnitude, that is nothing but area vector. So these were some of the examples. Now in this case, if I ask you to tell me the area vector, it is basically something like what? It is something like this. Yeah, exactly. So in this case, so can I say this is the sheet exactly placed over here? Now, what is the area vector? That will be in this y direction, in upward direction. So can I say this area vector will be exactly in j cap, or this area vector will be exactly in minus j cap, in downward direction or in upward direction? Because both of these vectors are perpendicular to this plane. Area vector, what is the direction of area vector? That is perpendicular to the plane. So in this case, that will be perpendicular to the plane, upward and downward. So over here, can I say basically it will be nothing but along this one, that will be the direction of this one, that is j cap, or this will be minus j cap. So how much will be the area? That is clearly how much? A is nothing but, what is the side? That is A, that is a square, or j cap, or A is nothing but a square minus j cap, a square minus j cap, minus a square. This j cap is exactly the scene over here. Okay, fine. Yes, a square in y direction. Now let's move. Let's talk about this one. In closed surfaces, we take only outward normal. If, for example, you are given a closed surface, okay? In that case, if I ask you what is the area vector, see how many faces are over here. You will say, sir, this is first face, okay? In this cube, how many faces? You will say, sir, this is the next face, okay? This is the next face over here, and this, there are 6 faces. So 6 faces will have the areas, understand? Over here, this will have the area, this will have the area, this will have the area. Now they will have direction as well, because area is a vector. Now in that case, you will tell me, sir, the area of this face will be, that is how much? If I say this is A and this is A, you will search the area of this will be nothing but a square. And what is the direction? You will say the direction is inward and outward. No, in case of closed surfaces, I suggest you to take the area vector in outward direction only. That direction of area which is only in outward, that's what we say outward normal, So over here, if I ask you what is the area vector of this face, you will simply say, sir, the area vector of this face is, first of all, magnitude is a square, and what is the direction? That is outward, not the inward one, outward normal. So what is that? Can I say this is in the x cap, this is in I cap, this is in x direction, so it will be nothing but I cap simply. Now if we talk about this one, this is the face facing over here. So in that case, I would say the area of this one will be A is equal a square into what? K cap, if this is facing what? In the outward direction. Same goes for this one. Area of this one will be a square into this k cap. Only take the outward normals. Don't take the inward normal. Okay. Now let's come on to the electric flux. What this electric flux is all about. Let me just give you the feel of this electric flux. What is this all about? Where does it come from exactly? Fine. Yeah, only positive. Take the outward only positive. Okay. Now, see what is electric flux all about. Now, if I say, for example, I have a charge, okay? If this is a charge, around this charge, there is electric field. Fine. Around this charge, there is electric field. If there is electric field around this charge, means how we can represent that electric field, I have told you previously, okay? There is a charge around this, there is a field. If any charge comes in that field, it will basically attract or repel that charge depending upon the charge of the other particle. Understand? Now, same is the case over here. If I say there is a charge over here, and if I say electric field is around this charge, now how can we represent that electric field? I have told you previously, we can represent that electric field by electric field lines. Understand? This is having some electric field lines over here, electric field lines, electric field lines, electric field lines, electric field lines, electric field lines. Means if I say electric field lines are over here, I can basically say electric field is present over here. That is the concept of that. Now, listen to me very carefully, very carefully. Fine. If I say this is the electric field, constant electric field, understand? Over here, this is a constant electric field moving like this, understand? In the rightward direction. Now, if I ask you, for example, yes, lines of force, electric field lines. Now, if I ask you, for example, there is a surface over here, imaginary surface, or simply say there is a surface, okay, piece of paper over here. And if I say, for example, this piece of paper is basically placed over here, how many lines are crossing this piece of paper? You will say, sir, 1, 2, 3, 4. So 4 lines are crossing this piece of paper perpendicularly. This is a piece of paper. Lines, this one line, second, third, fourth, means 4 lines are passing this piece of paper perpendicularly. So in this case, we say what? That is flux is 4. You'll say, now sir, what is this flux? Flux is basically number of field lines passing a given surface perpendicularly. So how many lines are passing this given surface perpendicularly? Now you have to basically take this as imaginary surface. That's why this basically represents over here how much electric field is basically passing through this one. Electric field lines are passing, means electric field is passing. So can I say how much electric field is passing through this one? That is nothing but flux over here. How much field lines are passing? 4 field lines perpendicularly. Now if I say in this case, how many field lines are passing? You'll say, sir, this 1, 2, 3, 4, 5, 6, 7. So in this case, I would say flux is nothing but 7. Why 7? Because these are the field lines passing this surface perpendicularly. Understand? These are the field lines passing this surface perpendicularly. Yes, exactly. So what is electric flux? It is nothing but number of field lines. How many number of field lines will basically cross perpendicularly any surface? You can take this as imaginary surface over here. Consider there is an imaginary surface. Now, how many electric field is passing? How many field? 50, 60, 70? It is something like that only. Okay. Now, if I say, for example, this electric flux depends upon what? If I say, for example, there is more electric field over here. Electric field strength is very strong. Magnitude of electric field is more. So can I say in that case, more field lines will pass? More field lines will pass? Definitely yes. Now, if I say, for example, electric field is basically less. Electric field is less. In that case, less number of field lines will pass, because more the magnitude of electric field, more will be field lines. Understand? For example, for Q charge, 4 lines are coming out. If I say, for example, there is 2 Q charge, 8 lines will exactly come out of it. That's why more electric field, more will be the field lines in that case. More will be the field lines in that case. So over here, can I say if electric field is more, electric flux will be more? It is directly proportional to this. More field lines are crossing this surface. So I can say flux will be more. Flux is what? Number of field lines crossing the surface, 100%. Now, if I say, for example, there is bigger area. Instead of smaller area, there is bigger area. Now, in smaller area or in bigger area, in which area the more field lines will basically cross? Obviously, bigger area. If you keep the bigger area, more field lines will pass over here. If I say, for example, in this area, how many field lines are crossing? You'll say only 3. Now, if I say how many field lines, these are the field lines, okay? These are the field lines. So through this smaller area, only 4 lines are crossing. Through this bigger area, how many lines are crossing? 1, 2, 3, 4, 5, 6, 7, 8. So area is more, field lines will cross, more field lines will cross. So in that case, we'll say electric flux will be more. Electric flux will be exactly more, 100%. So can I further say this electric flux is, if this depends upon electric field, if this depends upon area, so can I further say this electric flux will be nothing but E dot A? Now you will say, sir, why this dot product? Why not cross product or any other thing? Okay. Till here, everybody understood what is this concept? Okay. Okay, that's great. Now see, you have question in your mind, sir, why this dot product? Why not directly E multiplied by A? Why this cross product? See, if I say, for example, I have a surface, okay? This is the surface over here. This is the surface over here. It has some area. If I say the electric field is not a perpendicular to exactly. So electric field is something like this. This is the electric field at some angle. Understand? Crossing the surface. Fine. I'll just make it. Electric field is basically something like this. Now, what is the definition of electric flux? Number of field lines passing the surface perpendicularly. Understand? Yes, if the field, whatever that is, okay, even if that is charge at infinity, so field lines will be parallel. Even there is some machine creating the field lines, because of that, even if there is a machine which is creating the electric field, understand? So because of, even this is a battery, because of that electric field is being produced from this point to this point. We don't have to talk about that. From where the electric field comes, we have to talk about this thing, how many number of field lines cross. Understand? If there is an electric field, constant electric field, or even variable electric field, how many number of field lines cross? We have to talk about that. Rest, we don't have to talk about from where this electric field comes, from the charge, from whatever it is. We don't have to talk about that, okay? Consider it from a charge only, if you are getting that confusion in your mind. Now see, listen to me very carefully. If I say this electric field, if I say this electric field E is not perpendicular to this one. So this is a vector. It will have two components. If I say, for example, this is making theta with the horizontal. So this will be E cos of theta over here. So this will be, this component of electric field will be E sine of theta in that case. Can I say it like that? I resolved this in two components, 100%. Now, according to the definition of electric flux, what is that? Number of field lines, number of field lines, number of field lines, number of field lines passing through what? Number of field lines passing through this surface. Okay, that's what I am saying. You don't have to. These lines are imaginary lines. If you even, for example, consider that it is coming from something. Understand? I know field lines are imaginary lines. This is a charge, okay? This charge is creating the electric field around it. Understand? So we represent that by electric field lines. I know these are imaginary field lines, okay? How you can basically represent the electric field? You can represent in case of diagrammatically with the help of field lines only. I know these are not real. Understand? These are imaginary only. But what exactly is the definition of electric flux? That is what I am talking about. If you want to understand this field line, what this exactly is, this is imaginary, real. Watch my electric field lines lecture. I have cleared everything. What this exactly is. Why do we represent this electric field, this one? What is the density? Every damn thing. Yes, then everything over here is imaginary only. Have you seen the electron? Have you seen any other thing? Okay? The main point is we have to talk about the definition of that. Even Maddie, you understood what I am trying to say? So if I talk about, for example, this over here, in this case, if I say that what is electric flux, you will say electric flux is basically number of field lines which are crossing this surface perpendicularly. So which electric field lines is crossing perpendicularly over? That is E cos theta, not E sin theta. This is basically parallel to this one. Sorry, this is basically touching this one. This is touching this surface, or we can say in this case, where is the area vector? You will say, sir, area vector is this. So area vector, it should be along area vector only. This should be along area vector only, 100%. So in that case, if I ask you to tell me the electric flux over here, you will simply say electric flux in this case will be what? That is E dot A. Understand? What is that? E dot A. How much is electric field over here? This is nothing but that is this E cos of theta And what is the area vector? You simply say that is E. So can I just write this will be nothing but EA cos of theta. So what is EA cos of theta? Can I write it? It will be E dot A exactly. That's why we take this one E dot A. So that if the electric field is not basically what? Perpendicular to this one, we have to take that component which is perpendicular to the surface. Now, can you tell me what is the electric flux in this case? Find flux if electric field is passing. Okay, this is the electric field. Tell me electric flux over here through each phase, how much it will be? Come on, through each phase. Okay, now see, what is electric flux? E dot A. E dot A cos of theta. First, if you consider this phase, okay, this is the phase. This is the phase facing outside, understand? This is something like that. So this is the phase which is in this direction. This is the phase which is facing this outward direction, or you can basically consider this also like that. So if I say, for example, this is the phase 1, this is the phase 2, this is the phase 3, this is the phase 4, and 5, 6, understand? So this happens, okay? So 5, 6. So in that case, could you please tell me what is the electric flux in that case over here? Or you take this as this phase, okay? It should be something like this only, understand? So you'll say, sir, electric flux through this will be phi 1. So how can I calculate that electric flux through this phase? How much that will be? You will say, sir, that is this E multiplied by the area of this one. If the length of this is A, the breadth of this is A, so can I say this is A square, E into A square. And what is the angle between area vector and that? This is a closed surface. I told you, you have to take the area vector. That should be what? In outward direction, understand? Outward normal. So over here, this is the area vector. This is what is the angle between these two? That is 0 degree. So cos of 0, how much that is? That is 1. So this will be cos of 0 degree. So that will be EA square, obviously, over here. Fine. How many field? This is the surface. This is the electric field passing. How much is the area? That's A square. In this direction, X direction, understand? Now, can you tell me phi 2 over here? This was phi, consider this as phi 1, this is phi 2. Understand? This phase. In this case, can I say phi 2 will be exactly 0? Why this phi 2 will be exactly 0? Because this is facing outwards. This is facing outwards. So it is touching only this one. Yes, it is touching only this one. So in this case, the figure is not exactly the... I'll just try to make it more proper. No, that is more accurate. Okay. So basically you have to check the angle between E and A. Understand? So in this case, you will say phi 2 is 0. Let me just tell you, what is this phi 3? How many number of field lines are crossing this phi 3? 0. Understand? Why 0? Because this electric field is touching this. In this case, this is the area vector and this is the electric field. Angle between area vector and electric field is 90 degrees. So you will say, sir, E dot this A cos of 90 degrees, that will be 0 only. Cos 90 0. So electric flux in that case will be 0. Exactly. So now if we talk about this phase or here, so phi 4 will be how much? In this case, this is what? This is the area vector. And this is what? This is the electric field. In that case, we'll say EA cos of 180 degrees. Understand? So there will be -1. So minus EA exactly. Over here, flux will be minus EA. And if we talk about this phase, that is exactly at the back. So that flux will be again 0. Why? Because in that case also, this is the electric field. This is the electric field. This is the area vector over here for this phase. Area vector angle is 90. So no flux is over there. So that's why. So rest all other are basically 0. Rest all other are basically 0. Okay. So this is basically this one EA, positive EA. This will be negative EA. Can you tell me this one? This is something like this. Exactly. This is a very good question. If you can answer me this question over here. Come on. In this case, tell me what is the net electric flux? What is the net electric flux? Option A, 0. B EA sine of theta, EAB sine of theta, C EAB. Option D, I would just write minus EAB sine of theta. Tell me, how much will be the electric flux over here? See how many phases are there. This is the first phase, okay? Second, third, fourth, 5. There are 5 phases. We need to find the electric flux through all these 5 phases. If we talk about this phase, okay, if we talk about this phase, this angle is given over here, that is theta, okay? If we talk about this phase, let me just show you. This is a very good question. Now see. Okay, let me just show you. First, we'll talk about this phase, okay? If we say this is the phi 1, phi of this A, if A, B, C, D, this will be E, okay? Yeah. So A, B, C, D, A, B, C, D. Flux of this phase exactly over here. Okay, if this is theta, can I say this will be exactly theta? So in this case, this is the electric field. Understand, this is the electric field. And what is the direction of area? So this is it'll be something like this, outward normal. So it will be in this direction. So this is basically, can I say this is the direction of area over here? This is the direction of area over here. So if this is theta, and if we talk about this one, this will be theta, this is theta, this is theta, this is theta, this is 90. Can I say this will be 90 minus theta exactly in that case? So can I say over here, this is A, this is electric field E. What is the side that is B? This is A. So can I say electric field E, A? What is A? A is basically area. Area over here is A multiplied by B. That is A, B. And what is the angle over here in this case? That is how much? A, B. Yeah, exactly. Am I doing it correctly? Yes. EAB. Yeah, exactly. It has to be EAB. And yeah, what is the angle between this and this? This is 90 minus theta. So it will be what? Cos of 90 minus theta exactly in this case. Okay, fine. You getting me what I'm trying to say? See basically what I'm doing. So this is the surface over here. This is A, B, C, D. Area vector is perpendicular to the surface and electric field is in this direction. So angle between this and this is 90 minus theta. So that is EAB cos of 90 minus theta. What is AB? AB is basically over here. That is the area of this one, because area, length of this is A, breadth is this A. So length into breadth will be the area in this case. Fine. So we got this one, that is E. So can I just write it will be nothing but EAB sine of theta, positive. Fine. Now, can you tell me the electric flux through this phase? Electric flux through this phase, that is AFB. AFB. See, electric flux through this phase, that will be 0. Why it will be 0? Because this is the area vector, this is the area vector, and this is the electric field vector. What is the angle between these two? That is 90 degrees. So it will be 0. Understand? Cos 90, EA cos of 90. So that will be 0 in that case. What is the area electric flux through that phase? That is DEC. So phi DEC. How much that will be? Again, that will be 0. Why that will be 0? Because in that case also, this is the area vector. This is the area vector in that direction. It is something like this. This is the area vector and this is the electric field. Angle between these two is 90. This is 90. This is 90. This is 90. So in that case, can I write this will be also 0, 100%. Now remains what? This surface. Okay. So electric flux through this surface will be also 0. Why? Because this, if we talk about this surface, this is the surface over here, something like this. So electric field is in, area vector is in downward direction. Area vector is in downward direction. Yes, total will be exactly 0. So area vector is in downward direction. This is the electric flux, electric field. So angle between these two is 90. So can I say this phi FEBC? FEBC, it will be again 0. Fine. Now let's talk about this phase. This phase, that is what? Phi of AFDE. AFDE. How much it will be exactly? Now listen to me very carefully. See, if I talk about this one, AFDE. So this is basically something like this. What is AD? Yes, this length exactly. I'll show you it over here only. It will confuse you. Now see, if we talk about this B, so can I say this will be exactly B also? This will be B 100%. If this is B, see, this is theta. We don't know this length. We don't know this length, but we know this A. So can I say this will be nothing but this is theta? Can I say this is A? Can I say this is nothing but A sine of theta? A sine of theta 100%. Now, can you tell me this will be how much? That is E. What is area? Area is nothing but this length into this breadth, because this is a square. This length is how much? A sine of theta. Breadth is how much? B. That is this A sine of theta multiplied by this B 100%. And what is the angle between these two? What is the angle between these two over here? In that case, this is the area vector in the outward direction. Direction of this area vector. Electric field is in forward direction. Can I just write this will be cos of 180, 100% angle between this and this exactly. So in that case, how much it will be? It will be minus EAB sine of theta. This is minus 1, so EAB sine of theta. Now, if I ask you to tell me that phi net will be nothing but how much? It will be this 0, 0, 0. So simply it will be EAB sine of theta minus EAB sine of theta. EAB sine of theta minus EAB sine of theta, it will be 0. So net flux will be 0. Yes, it is 0. Understood? You got it? How I exactly did? See, this you are talking about, see, this is B, this is B. We don't know this length, but we know this A. This is theta A. A of this one, this is A sine of theta. Yes. Now, listen to me very carefully. That is electric flux through a non-uniform electric field. How do we represent the non-uniform electric field in case of electric field lines? Tell me, how do we represent the non-uniform electric field in case of those imaginary lines that you were talking about? Fine? Okay. Now, see, if I say, for example, there is a surface, something like this over here, okay? And electric field, this is the constant electric field, we represented something like this. And this is something variable electric field, understand? Direction not constant, magnitude not constant, both. Over here, direction is same and magnitude is same. This density tells us the magnitude between the electric field. If this density remains same, so we say magnitude is basically same in that case. Now, see, if I draw the electric field over here, something like this, something like this, something like this, something like this, okay? In this case, I would say this electric field is not a constant, this is variable. Now, listen to me very carefully. If I say, for example, you need to tell me how much is the electric flux in that case. How can we exactly find this one, okay? Variable electric field, not a uniform electric field in this case. You will say, sir, it is very simple. How? You take that integration method that we have been doing since decades. So what do we exactly do? You are saying, sir, over here, you take this very small area, that is this dA, understand? So this is the area dA. And what is the direction of this area vector? We say that is in this direction, that is nothing but this is dA, understand? In outward direction. You will say, sir, if this electric field is passing, this electric field is passing through this only, this is E, understand? Now, can you tell me through this very small area, how much will be the electric flux? That will be very small. So you will say, sir, that is how much? That will be d phi. We call it very small electric flux, okay? Very small. Now we will say how much that will be. See, electric field is variable over here, but for this very small area, it will be a constant. We can take it constant. We have been doing this from very long time. So can I say this will be nothing but E dA in that case over here? E dot dA, 100%, okay? E dot dA. Can I do it like that? Yes. Now if I ask you to tell me the net electric field in that case, you'll simply integrate this, you'll get the net electric flux. If I ask you to tell me the net electric flux in this case, you'll say, sir, integrate this, you'll get the net electric flux. So in that case, can I do it like this? This will be integration of this. D phi is integration of this E dot E dA, and this will be cos of theta. What is the angle between this and this? That is 0 degrees. So cos of theta. So can I say this will be phi? It will be phi total. That is nothing but E dA cos of theta in that case. This is the formula for that. Understand? Okay, now let me just basically explain you this Gauss law through this beautiful example. Fine. Okay. What is the time? 6:52 already. Oh. Now listen to me very carefully. I'm saying that in this case, electric flux through a closed space. Electric flux through a closed sphere. It is not space. Okay, sphere. I'll make you explain this Gauss law, what it exactly is. So basically, this is a sphere over here. Okay, this is a sphere over here. I'm just making the sphere. There is a charge Q placed inside this sphere. Okay, this charge Q is placed inside this sphere. Now, if I ask you to tell me the electric flux over here, you will say, sir, it is very easy. We can definitely use this one. Okay, we can definitely use this one in order to find the electric flux. Now see, take a small element over here. Take a small element over here. I'll tell you how we can exactly find the electric flux through this one. Take a small element over here that is at r distance from this one. Can I say this is at r distance? So the area of this one, can I say this will be nothing but a dA? 100% this will be dA. Now because of this, the electric field will be produced. This is a charge Q placed inside. Because of this, electric field will be, understand? So electric field will come out. These electric field lines will come out from this 100%. So I'll just represent that electric field over here. So through this very small dA, how much will be the electric flux? Very small electric flux, because we say flux is nothing but number of field lines crossing the surface. So over here, flux will be very small. So can I just write that as a d phi is nothing but that is E dot this dA exactly. Fine. Now you tell me one thing. If I ask you what is the angle between this and this, tell me the magnitude. You'll say, sir, that is very easy. D phi is equal E dA, that is cos of 0 degrees in this case, because this electric field and this dA vector both are in the same direction. And in case of a closed surface, we take this dA and we take this area vector in the outward direction only 100%. So can I just write this d phi will be nothing but E dA in this case only 100%. I can definitely write it like that. Now you tell me one thing. If we want to find the total electric flux through whole sphere, this is the sphere, electric, how many number of electric field lines are passing perpendicularly through all the sphere, understand, through all of its surface. You will say, sir, it is very simple. What do we exactly do? We need to basically integrate this one. So this will be integration of this one. So it will be phi only. If we talk about the whole sphere, we'll get the total flux. So can I say this will be nothing but integration of this is E dot A exactly in that case. Okay, simple, very simple concepts I'm using over here. Now you tell me one thing. You tell me one thing. See, if I say for example, this phi. Now see, electric field, can you tell me at this point because of this charge? If there is a charge, because of this charge at any point, if you want to find the electric field intensity, okay, how can you basically find? That is kq by r square, 1 by 4 pi epsilon. If this is r, at this point it will be 1 by 4 pi epsilon naught q by r square in that case. So can I say in that case it will be nothing but 1 by 4 pi epsilon naught, that is this q, what is placed inside, upon this r square, where r is the radius at this point. 100% can I say it like that? Can I say this electric field, which is exactly for this, it will be same for this also? Why? Because this is at same radius, this is at same radius, this is at same radius, this is at same radius for all these, and they are dA, 100%. Now, and it will be dA over here exactly. Now you tell me one thing. This is constant, this is constant, this is constant, this is constant, everything. This r is also constant for this one, this r is constant, for this one this r is constant, for this one this r is constant. Understand? Because we are taking these small dAs, we are finding the electric flux through all of these dAs. What is the concept exactly? The concept is you find the electric flux through one small dA, then you divide this entire sphere in infinite number of small dAs. You find the electric flux through all of those dAs and you add them up by integration, and you will get the total electric flux. That is the exact concept. So in this case, can I say this will come out? So phi will be nothing but this will come out, that is 1 by 4 by epsilon naught, and this will be q by r square. This will also come out integration of this dA exactly. Understand? This dA exactly. Now what is this dA? Integration of this dA. We need to integrate this. See, this integration of dA means that this is dA, this is dA. So how many dAs are on this sphere? Infinite number of dAs. So if we integrate all of these dAs, we'll get the total, what? Total surface area of this one. Total surface area of this sphere. So that is what we need to put over here. So what is the total surface area of a sphere? You might have studied that in your 8th class. That is 1 by 4 pi epsilon naught as it is. This is q by r square, and total surface area of sphere is nothing but 4 pi r square. So this r square will cancel. This 4 pi will cancel. So we will get, that is nothing but this q, which is inside upon this epsilon naught. Means if you have any closed surface, charge is placed inside that closed surface, the flux through that closed surface will be q by epsilon naught. This is the Gauss law. What does Gauss law exactly say? Gauss law says that total electric flux linked to a closed surface is equal to the 1 by epsilon times the charge inside the closed surface. Understand? If there is a closed surface, okay? If the charge inside is q, and if we are asked that find the electric flux through this closed surface, it is nothing but phi, simply is nothing but q. What is inside? How much is inside? That is q. This q upon this epsilon naught. Proof I showed you over here, okay? This is the electric flux through any closed surface, okay? Now you tell me one thing. How much will be the electric flux if I say charge q is basically inside? This q is basically inside. How much will be the electric flux? Can I say this will be q by this? It will be nothing, q inside by this epsilon naught. This, if there is this cylinder, this is a closed cylinder. Over here, charge is placed inside through this. It will be nothing but q by epsilon naught. Understand? Any closed surface. This is basically the Gauss law. It states that is 1 by epsilon times the q inside. That is what we say. Q inside by epsilon naught is the q net. Okay, fine. Now can you tell me in this case how much will be the, what will be the answer? If I say, for example, this is q1 inside, this is q2 inside. Okay, this is q1, this is q2, and I'm placing the q3 outside. How much will be this one? In this case, you need to basically find this exactly. Come on, afterwards we need to solve some of the problems as well. Now see, according to Gauss law, the charge placed inside will produce how much of flux? Q inside by epsilon naught. Fine. Now there is charge. This is outside. Understand? This is kind of system of charges. This is q1, this is q2, this is q3. So this is a closed surface. This is a sphere over here. Can you tell me? See, we know phi is equal to q by epsilon naught. So what is this phi? That is E dot dA. Integral of E dot dA. Integral of E dot dA. Integral of E dot dA. Understand? Studied previously. Now you tell me one thing. If, for example, for this charge q1, this is providing the electric field E1. So can I just write E1 dot dA? It will be equal to q1 by epsilon naught for this charge q1 only. 100%. How much flux it will? This E dot dA is flux. Instead of this flux, we are writing E dot dA. Integral of E dot dA, net flux. So, and it will be how much? Flux, that is q inside by epsilon naught according to Gauss law. So q1, how much is the charge inside? That is q1 if we are talking about the q1 particularly. So that is q1 by epsilon naught. Similarly, can we just write for the charge number 2, that is E2 dot this dA is equal to how much? That is E dot dA. This will be how much? That is q inside by epsilon naught. That is q2 by epsilon naught. And if we write E dot dA as cos of theta in that case, understand? Cos of theta. Can I just write it like that, or simply you just write this one only? E dot dA. E dot E vector dot dA vector. This will be for, so for E3 dot this dA, can we just write this will be q3 by epsilon naught? 100%. Getting me what I'm trying to say? Now the point over here is, you tell me one thing. in case number 3, in charge number 3, is this charge inside? This is basically charge inside. Is this inside charge? No. So can I say this is basically Q inside? So Q inside in this case is basically 0. If Q inside is 0, so this term will be 0. In that case, this flux. So can I say in that case, this phi 3 in that case, can I say this will be exactly 0 because this is 0. So exactly this will be in that case 0. E dot dA will be exactly in that case 0. E3 dot this dA will be exactly 0 in that case. Everybody understanding this one? Yes. Exactly. This will be the answer. So in that case, because we say this will be exactly 0. Now, if you want to find the total flux through this one, so can we just write it? It will be nothing but integral of this E1 plus this E2 vector plus this E3 vector, and this will be dA vector. It will be nothing but that is Q1 by epsilon naught. This is the flux through first, plus Q2 by epsilon naught flux through second, plus flux through 3, that is 0. So this will be basically, so can I just write this will be E net, this, remember this formula from now onwards, E net dot this dA. Understand, it will be nothing but that is Q1 plus Q2 by epsilon naught. Okay, this Q1 Q2 is the charge inside. So remember this. Now you can use directly E net dot dA. It will be nothing but how much charge is inside this Q inside. So simply you can just write it nothing but Q inside only upon epsilon naught. Understand? Q net inside. Okay. Now find flux through one of its faces. You need to find the flux through one of its faces. Come on, can you tell me? In this case, happy birthday, Yawar sir. What is the date today? 6 September. It's not my birthday. So can you tell me flux through one of its faces? The charge is placed inside. Come on. Through this entire cube, this is a closed surface. Over here, can I say flux will be nothing but Q by epsilon naught, Q inside by epsilon naught, 100%. Through one of its faces, how much that will be? Can you tell me? Okay. See, this is flux through entire cube. That means how many faces are there? There are 6 faces. So through 6 faces, it is phi. Understand? Means through 6 faces, it is Q by epsilon naught. So can I say through one face, it will be phi by 6. That will be nothing but this Q by 6 epsilon naught. Very simple. Okay. Through 6 faces means through entire cube, it is Q by epsilon naught, because according to the Gauss law. Through 6 faces, because there are 6 faces, it is phi. That is Q by epsilon naught. Through one face, how much it will be? Phi by 6. That is Q by 6 epsilon naught. Okay. This is a very good question. I want you people to solve this at your own. Afterwards, I'll be showing you the answer of this question. Tell me what is the electric flux over here? Flux passing through the square. Flux passing through this square. Okay. The electric field is in this direction. So E is equal to AX. This is not AX. This is alpha X. This is alpha X, this K cap. And this is the electric flux. Okay. This is in the K cap direction, Z direction, positive Z direction. This is the... Yes. Now tell me the answer of this question. Tell me the answer of this question. Okay. See, electric flux over here is not constant. It is variable. Electric flux depends upon X. So at a different X, over here electric flux will be something. Over here electric flux will be something. So it keeps on changing. Electric flux varies with X. X varies, electric flux varies. Okay. So over here clearly electric flux is not constant. Understand? So how can you find the electric flux in case of a variable electric field, non-uniform electric field? This is the
concept. You take a small element, understand? So you find the electric flux through that element. You take another small element, you find the electric flux through that element. So you cut infinite number of elements on this surface, You find the electric flux through all of these small elements and you add them up by integration. Small electric fluxes. Add all of these small electric fluxes, you'll get the net electric flux through this surface. That is the thing what we're gonna be doing over here. Now this is a surface over here, understand? So if we'll basically find the electric flux through this, as electric field is not uniform, understand? So we'll find the electric flux through this one. If I say this is x, so how much this will be? Can I say this will be nothing but it will be dx 100%. And what is the length of this one? That will be how much? This will be a exactly. Now tell me how I can find the electric flux. See, d phi I can find very small electric flux because through this is a very small strip, infinitely small strip. So through this strip, can I say electric flux will be infinitely small? So that will be nothing but d phi. I call that d phi. How much that will be? E dot dA. Understand? E dot dA cos of theta. Can I say it exactly like that? So in this case, what is the area vector? This is in y explain. So it is something like this. So area vector will be something like this. Can I say this will be the area vector? That is a dA. In this case, in z direction only, also in k direction, in k cap, 100%. Okay, so can I just write over here electric flux? How much? E. What is the electric field over here? That is this alpha x. So can I just write this will be nothing but this alpha x and this will be k cap exactly. We can just write it like this also because they are both in the same direction, cos 0 in that case. So alpha x, and what is this dA? This is also in this direction. That is nothing but how much is the dA? We need to find this dA. Chalo, I'll just write dA. That is also in this direction. Cos of 0 degrees between these two. I can simply write it like that also. Now, what is the value of dA in this case? You will say, sir, this is very easy. This length multiplied by this breadth. So this is a dx exactly. In which direction? K cap direction. Now put it over here. So you will just write d phi is nothing but alpha x, and this will be what? This will be a dx exactly. So it will be a alpha x dx. We got the d phi. So this much is flux. This much amount of flux is basically passing through this one strip, infinitely small strip. I'll get back to my previous look once again. Don't worry about that. Okay, so can I just write it will be nothing but this d phi is nothing but, if you want to find the total electric flux, that will be from 0 to phi. Understand, this is pi, 0 to phi. So it will be nothing but integration of a alpha x dx exactly. You tell me one thing, from where to where? So this strip is over here exactly. Now we have to vary this from this 0 to how much is this length? That is a, because we are cutting this length in infinite number of small strips. Understand? Then only we found the electric flux due to all those strips, and we are adding them up and we'll get the total electric flux. From 0 to a, we'll get the net electric flux. So can I say this will be phi net in that case? This will be nothing but alpha, a, alpha, both are constants, okay? Alpha and a are constants, okay? So this will be nothing but from 0 to a, this is x dx. This will be a alpha, it will be x square by 2 exactly from 0 to a. So it will be nothing but a alpha, and it will be, instead of this x, we'll just write a square by 2. It will be nothing but alpha a cube by 3. Alpha a cube by 3. Fine, you got it. Shall I move on to the next one? Tell me how much will be the electric flux through this one. Okay. What do we call this? That I don't exactly remember. Yeah, hemispherical surface. Okay. Chalo, can you tell me how much will be the surface area of this one? Electric field is E. This is the constant electric field. So flux will be nothing but E dot area of this one. That is nothing but pi r square, I guess. Okay. Yeah, that's great. Come on. Tell me, a charge is placed at the top of a semi-cylinder. find the electric flux through it. See, I'll tell you how it is exactly. So this is basically a semi-cylinder. This is exactly a semi-cylinder. This is, I know this is a full cylinder. You consider this as a semi-cylinder. There is half of the part from the upper side also. So at the top over here, the charge is basically placed. Okay, you need to tell me the electric flux through it. Come on, how can you exactly find it? And like this session, everybody. Come on, can you find this one? Tell me how much it will be exactly. What do you have to do with the curve with surface area, man? B. Yo. Let's see how is it going to be. See, what the Gauss says exactly. If there is a closed surface, charge is placed inside that closed surface, how much will be the electric flux through that? If I say, for example, that is a cylinder even, okay, this is a closed surface. If I say charge is placed inside this one, flux will be through it, that is Q by epsilon naught. Proved it already. This is according to the Gauss. Understand Gauss law. Now, the point over here is this is not inside. So if we say, for example, there is half of it, this is the imaginary half cylinder, so we'll try to make it the full one. So now is it full? So now this is inside. So for this entire cylinder, how much will be the flux? That is Q by epsilon naught, okay, because this is inside for this entire cylinder. Now this is half only. For half, how much it will be? It is very simple. That is Q by this 2 epsilon naught. Okay, Vidya. Come on. Let's go for this one. Tell me. A charge is placed at a corner of a cube. Find the electric flux through one of its faces. Yes, this is a very good question. See, I'll show you how it is exactly. It is something like this. Okay. This is the charge placed over here at the corner. Tell me, what will be the flux through one of its faces? Through one of its faces. This. Come on. And no, man. How B? Come on, can you tell me how much it will be exactly? A, no, exactly, not exactly. Come on, all of you, solve this. See, if this charge was inside, in that case, you will say basically Q by 6 epsilon, because through this cube, if I say this charge is placed inside, so flux through the closed surface will be Q by epsilon naught. Through one of its faces, there are 6 faces, that will be Q by 6 epsilon naught. But this is not inside, this is over here. Now, you have to basically make such a figure so that this charge will come inside. Make a symmetric figure. So how can you exactly make? You will attach basically this one cube from this side, one cube from this side, one cube from this side, one cube from this side. How many cubes you need to basically attach to this one so that it will come at center? I guess 5 cubes, okay? So exactly then this will be exactly at a center, okay? In that case. So total number of cubes then will be 6. It will be 6 then. 5 you need to add, 1 is over there. So in that case, flux through this entire system, when there are 6 cubes, flux through that, how much will be that? Can I say that will be nothing but Q by epsilon naught? Can I say it will be Q by epsilon naught? Understand? So through one of its faces, in that case, through one of its faces, how much that will be? Q by 6 epsilon naught. Understand? Now, how many faces are there in that case? Can I say there are 5 cubes, and how many faces are there? It will be 6 into 5 exactly. No, 6 into 8. So can I say this will be nothing but 6 multiplied by 8 epsilon naught? It will be Q by 48. Understand? 48 epsilon naught. So this will be the correct answer. Understand? Flux through each phase. Flux through each case.
Yes, exactly 8. Yeah, flux through each phase. Yes. You getting me what I'm trying to say? Let's move on to the next one. Can you tell me what is the electric flux due to charge q placed at a center of a cylinder through the curved surface? Yes. Okay. Can you tell me this? Through the curved surface only. See what you are supposed to tell me. Charge is placed at the center of a cylinder. Now, this is the cylinder, okay? It is something like this. It is something like this, okay? So charge is placed over here. You need to tell me what the electric flux through this curved surface only, through this curved surface, not through this surface, okay? Through, what do we call this surface? This is the curved surface area, okay? Not through this A surface, X surface, okay? Yes, definitely. I'll make you my gym partner. Where are you from, Ahmad Sulaiman? Ahmad Sulaiman. Do you pronunciate your name like this only? Come on, can you tell me the answer of this question? Okay, that's great. You are from Chennai. Okay, can you tell me in this case how you can exactly find this one? See, you need to basically find the electric flux through this one, okay? How you can exactly solve this one means the flux will be through this, flux will be through this, flux will be through this, flux will be through this. So flux will be through this, flux will be through this, through this, through this, through this. So is this some sort of cone over here? Array, 1 second. Over here, there will be 8. There will be 8 cubes. Understand? Not the 7 cubes. It will be 8. Why 8 cubes? Because we need to attach 7 cubes more than only this will come at center. Understand? Not the 6 cubes. So it will be 8 into 6. It will be 8. Flux through each phase. That will be q by 8 epsilon 8 into 6. 8 q by 48 is the correct answer. But remember, you need to attach 7 cubes. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, exactly. So there will be exactly 8 cubes. You need to go this one. Okay. Now, see, from this one, if I ask you over here, listen to me very carefully. You need to basically find the electric flux through this entire cylinder first. Flux through this entire cylinder, how much will be? You will say, sir, that will be q by epsilon naught. Q is placed inside because this is a closed surface. Q by epsilon naught. Fine. Yes, yes, exactly. Thanks. Okay. Okay, so in that case, that was a bit confusing, okay? This is the first cube, second cube, third, 4, 5, 6. That's why. Okay, now listen to me very carefully. So, how much is the flux through this entire cylinder? That's q by epsilon naught. Now, we need to find the flux through this only. This flux we need to find. This flux through this curved surface area only. This curved surface. Understand? If this is a cylinder, okay? Flux through this, not through this and this. Understand? These two areas. Now, in that case, so this is some sort of cone. Can I say this is nothing but this is a cone, flux through this cone. We need to subtract the flux through this cone. We need to subtract the flux through this cone exactly. Okay, we need to subtract the flux through these two cones. First, we'll find the flux through entire cylinder. That's q by epsilon naught. Then we'll find the flux through this cone. We'll find the flux through this cone. And that will be how much? We'll subtract this from this exactly. We'll get what? We'll get basically the net flux through this curved surface area only. This is the concept. I want you people to basically solve this at your own exactly, okay? Come on. I'm waiting for your answers. What will be it? This has to be the answer. Come on, how can you exactly solve this? Listen to me very carefully. Now see,
if I talk about the flux through cone, just I haven't basically told you the derivation of this one. I'll show you in some other class the derivation of this one. Flux through each cone, exactly it will be nothing but this q by 2 epsilon naught 1 minus cos of theta. So where this theta is exactly this angle. How much is this angle? So obviously it will be how much? It will be 45 over here. So can I just write, it will be simply flux through this each cone, that is q by 2 epsilon naught, and it will be 1 minus cos of 45 1 by root 2 exactly. So this is flux through what? Each cone. There are 2 cones, so flux through 2 cones, how much that will be? Q by epsilon naught only. So q by epsilon naught 1 minus 1 by root 2. Now you need to basically find the flux through the curved surface area only. So we got the flux through this, so total flux minus this flux will get the flux through these only. So it will be nothing but flux through the curved surface area only. How much that will be? This q by epsilon naught minus this q by epsilon naught 1 minus 1 by root 2 exactly. So it will be this q by root 2 epsilon naught. So which part is the answer? This one. Okay, now we need to move on to the application of Gauss law. Fine. Now see, where is basically the Gauss law exactly applied? Listen to me very carefully now. See, we say basically this application of Gauss law we say this application of this Gauss law, that if we have a rod, understand this is charged, this is infinitely long, this is infinitely, understand what? Long. Understand there is infinite charge on this also, okay? Infinitely long charged wire. We don't know exactly how much amount of charge is present over here, but we know the charge density. Exactly in this case. Now what we are supposed to find in this case is, what do you want me to repeat? This one? So what we exactly did over here, we found the electric flux through the entire cylinder, okay? Then we subtracted the flux through this, flux through each cone is how much? That is q by 2 epsilon naught, this one, okay? I'll show you the derivation of this one in some other class. And flux through this cone, When we talk about the 2 cones, so it will be q by epsilon naught, this one. Now, this flux through this entire cylinder minus the flux through the 2 cones will get the flux through what remains over there, only the curved surface area. So we got the flux through this curved surface area only. Now listen to me very carefully. If we have this infinitely long charged wire, yes, I'll make you my gym partner, don't worry about that. Okay, so this is the infinitely long charged wire, okay? So in this case, we don't know the exact charge because this is infinitely long. How we are supposed to find the electric field due to this? If this is a limited charged wire, in that case, we basically found the electric field in case of electric field distribution, okay? Distribution of charges. Over there, we basically got the electric field of that. How can we find the electric field in this case? How can we exactly find the electric field in this case? So this is the application of Gauss law. By the help of Gauss law, we can exactly do this. So I'll just try to make the figure exactly over here. So this is the figure. So this is positive charge, okay? Now if I say, if you want to find the electric flux through this, you make an imaginary Gaussian surface. This is the rule. Afterwards, you will get that exactly. So what will be that over here? That symmetrical Gaussian surface will be cylinder over here, okay? Symmetrical Gaussian surface will be cylinder over here, okay? So this will be the Gaussian surface over here in that case. Now you just tell me one thing. We need to now apply the Gauss law in order to find the electric field due to this one infinitely long charged wire. Now you tell me one thing. How much will be the electric flux? This is infinitely long, okay? How much will be the electric flux through this cylinder in that case? Can you tell me how much will be the electric flux through that? In this case, you will simply say, sir, electric flux through this cylinder, it will be simply by applying the Gauss law. So electric flux, this cylinder, it will be nothing but integration of E dot this dA. Can I just write E dot dA? That is nothing but charge placed inside, that is Q inside by epsilon naught. Okay, that is Q inside by epsilon naught. How much is the Q inside? We don't know how much is the Q inside. We know that is the charge density. Understand? Charge density lambda. Understand? In that case, how much is the charge present at per unit length, that we exactly know in that case. So this is the concept that we can exactly use over here. So in order to find the electric flux. Now, you tell me one thing. Flux through this cylinder means flux through the curved surface area, flux through this area, flux through this area. Understand? So we call this as flux through flux 1, we call this as phi 2, and we call this as phi 3. We'll find this phi 1, we'll find this phi 2, we'll find this phi 3. By using the same formula, we'll get the net electric flux in that case. Afterwards, we'll find the electric field, how much that will be exactly. So can you tell me in that case, how much will be the electric flux through this cylinder? You will simply say, sir, electric flux through this one. So electric flux through this surface area. So that will be how much? Integration of that is E dA. What is the angle over here? See, in this case, how much is the angle? This is the electric field. This is the electric field. This is the electric field, and this is the surface area also. Angle between electric field and this surface area. Am I going too fast? Okay. Am I going too fast? Okay. I'll slow down my speed. Don't worry about that. Okay. So over here, see, in this case, you need to basically change, you need to take what? This cylindrical surface. Why? Because at every point, flux will be then same. At this point, at this small surface, at this surface. Forget about these, because over here it will be E dot dA cos of 90 degrees. In that case, over here flux will be zero. Forget about these. So over here, in this case of curved surface area, if you want to find the flux at this point, E dot this dA, so it is at same distance over here. At this point, same distance. At this point, then only we can integrate it and we'll get the total electric field. Okay, fine. So can I just write in that case, in this case, this flux phi 1 will be what? This is electric field, and this is the area vector in this case, that is in the upward direction. What is the angle between these two? That is nothing but cos of 90 degrees. That will be cos of 90 degrees. Okay, we are finding the total electric flux through this one, flux through this one, flux through this one. That is our goal. Rest we'll talk about later what it will be exactly. So this will be plus integration of flux through this one, that is phi 3. Okay, we'll find the phi 2 first. Can I just write that is E dot this dA exactly? And what is the angle between this and this? That is cos of 0 degrees plus integration of E dot this dA cos of 90 degrees, because over here this is the area vector. Okay, this is the electric field. Okay, angle between these two. Fine. So how much exactly we got over here? So that is nothing but cos 0 is, so this will become 0, this will become 0. So we got exactly, can we say this is nothing but E integration of E dot this E dA, exactly we got it. Fine. Can we say it like that? Electric field, this electric flux of this cylinder in that case is came out to be exactly like this. So we got this E dot dA because of this charged rod in this case of, in case of this cylinder. Fine. Now the point over here is, we need to apply the Gauss law. What does that say? That is flux is equal to nothing but Q inside, electric flux through any closed surface is equal to Q inside by epsilon naught. In that case, 100% I can write it like that. So how much came out to be the electric flux over here in this case? That is E dot dA. Can I just write integration of E dot dA is nothing but this Q by epsilon naught over here? Okay, any confusion till here? I just need to know in the live chat. Okay, any sort of confusion? Can I just write this is Q inside only? Okay, fine. Tell me. So can I just write this will be Q by epsilon, this will be integration of this, take this E out, you will say why E out? Because for this every, see, for this dA, for this dA, for this dA, for every dA, electric field will be same because of this charge. Understand? They are at the same distance. This is very small, for this very small. Understand? So in that case, this will be nothing but a dA. dA, that is curved surface area of the cylinder. That is what 2 pi RL. So can I just write this will be Q by epsilon naught A into 2 pi RL. Exactly. Yes. So this charge, we don't know this charge exactly, but we know the charge per unit length. Understand? So lambda is nothing but a Q by L exactly. So because L is, we say this one in that case. So what is this? Q is the charge over here. So can I just write charge per unit length? So can I just exactly the main is this? Yeah, exactly. The main is this dq by dl. For very small charge, it will be lambda is basically what dq by dl, charge per unit length. For very small length, it will be very small charge per unit length exactly. Understand? I have basically explained this previously. So this q will be lambda times of L in that case. So can I just put it over here? That is lambda L by this epsilon naught. Okay. So it will be nothing but E 2 pi RL. This will cancel. E is nothing but lambda by 2 pi R epsilon naught. So this is the electric field because of this one, where lambda is the this linear charge density. Okay, you got it? Yeah, exactly. This channel is so underrated, Sulaiman. Your name is so good actually. Okay, I seriously like it a lot. Okay. The channel will grow for sure because we have recently started it. Fine. Now, electric field due to a plane sheet of charge. Electric field due to a plane sheet of charge. Same is the case over here. You need to basically take that surface, okay? Gaussian, make an imaginary Gaussian surface and try to solve this one. Come on, I just need to know in the live chat what will be the answer of that exactly. Can you tell me? So over here, we'll make the Gaussian surface. Make this cylinder, okay? Fine. So over here, electric field will be in this direction and this will be the area vector in that case. So over here, this will be the area vector in that case. Okay, electric field will be in that direction. So over here, flux through this will be 0, flux through this will be 0. Why? Because E dot A exactly. Okay, sorry, flux through this will be something, flux through this will be 0 because this is E dot A cos of 90. This will be the area vector in that case through the curved surface area. Yes, definitely. Okay, fine. Now in this case, can you tell me what is the what is the flux through this entire cylinder? You will say, sir, flux through this entire, same method we need to use in this one also. Flux through this entire cylinder will be nothing but, if I say this is phi 1, this is phi 2, okay, flux through this one, and this is phi 3. So phi 1 will be how much? That is integration of E dA cos of 0 degrees plus flux through this surface, flux through this surface, and flux through this surface. So integration of E dA cos of 0 degrees. Okay, then flux through this surface because it is creating the 90, so it will be E dA cos of 90 degrees exactly. Okay, can we just write it like that? So this flux through this cylinder will be nothing but, this is nothing but what? Cos 0 is 1, so it will be E dot dA. So can I just write E dot this integration of electric field will take out plus this integration of E dot this dA, the same method that I did previously. I'm doing the same thing. Okay, so in this case, can I E dot dA, it will be EA. So I'll just write over here, later on we'll put the value of this A exactly, or we'll cancel out this A. So we'll get integration of dA is what? Total area. So this will be nothing but this total area, that total area. Okay, because we'll cancel it later on. We don't have to put the surface area of this one. Don't worry about that. So it'll be nothing but twice EA exactly. Now what is this? This is flux through this entire cylinder. Now, flux through this entire cylinder, charge is placed inside, this much of charge is placed inside. In that case, if we use the Gauss law, that is Q by epsilon naught. So can we say this is nothing but Q by epsilon naught is nothing but 2EA, exactly 100%. Can we just write it like that? Can we just write it like that? Any sort of confusion do you have over here? I just need to know in the live chat. Come on. Now, can I just write in this case sigma? That is surface charge density. We don't know the exact charge, how much is placed over here. So we know sigma. Sigma is what? Surface charge density. That is what? That is this Q by charge per unit area. This charge per unit area, Q is sigma times of A. So now put it over here instead of this Q. That is sigma A. Why are we changing this Q? Because we don't know the exact value of Q. So this is infinitely long sheet. Okay. So over here, we are basically saying that we know what sigma, that is how much charge is present on unit length, on its unit area. In case of length, on its unit length, how much charge will be present, that is lambda. So that's why lambda A by this epsilon naught 2, this will be EA, exactly this will cancel. E is equal to sigma by 2 epsilon naught. So this is basically the application of Gauss law. It helps us to find the electric field of complex systems. Understand? Now, electric field due to charged spheres. Okay, let's basically go for this one. Can you solve? Can you tell me? SC Verma NF for what? Mains, advanced, NEET. What are you talking about exactly? For JEE, you have to basically solo a lot. Okay, SC Verma will only help you how you can use the concepts in problems. Understand? That's having a good problems. Understand? Having a good level, that is mandatory. Okay, SC Verma is mandatory, but apart from that, you need to go for some other books as well. You need to go for some other material as well, like mock tests, the sheets, core sheets, whatever it is. Okay, you have to follow every damn thing. That's great. Charge is placed on the surface. Okay, electric flux, we are supposed to find electric field. Okay, over here, how much it will be exactly? Simply use the Gauss law. We can find the electric field over here. Okay, at this, if I'm saying inside, okay, inside point P. For example, I'm saying this point P, this is at R distance, this is at R distance. This is the R radius and this is at R distance. In this case, R is less than R. Okay, fine. So over here, we can definitely use the Gauss law directly. E dot integration of E dot A cos of theta. So that is integration of E dot dA cos of theta is nothing but equal to QIN by what? This epsilon naught. Q by epsilon naught. How much is the charge inside? 0, because charge is on the surface of this sphere. So it will be 0. So can I just write integration of E dot dA? This will be nothing but, it is nothing but a 0. So electric field in that case inside will be 0. Fine. So this is the first case. By using the Gauss law, we can definitely find this one. See, we are using the Gauss law in order to find the electric fields over here. This is the second case. On the surface I am talking about, this is R. So in this case, this small r is equal to the capital R. You need to tell me the electric field at this R over here on the surface. Can you tell me how much it will be exactly? Come on. Q is the charge placed on the sphere, okay? Simply use the Gauss law over here also. That is integration of E dot dA cos of theta is equal to Q inside by epsilon naught, okay? Can we just write it like that? You tell me one thing. If I say, for example, over here, E dot dA, how much will be the electric field over here? How much will be the electric field over here? At this point, you will say, sir, because at this point, if I say, for example, at r distance, okay, it will be on this, for example, electric field is A and this is a dA. And in that case, what is the angle between this and this? That is cos 0 degrees. Can we say it like that? It is cos 0 degrees, 100%. Now, in that case, can I just write it over here? Can I just write it over here? It will be nothing but cos 0 E dot dA only. Take the electric field out. So it will be E dA cos of 0 degrees is QIN by epsilon naught. So I'll just take this electric field out. So it will be integration of dA only, that is QIN by this epsilon naught only. Okay, this is just a question. Okay, so this is E integration of dA. What is integration of dA? dA means you are adding all the dAs that I told you previously. You are adding all the dAs, understand? In that case, when you add all the dAs, you will get the total surface area of this sphere. How much? That is equal to 4 pi r square, okay? Can we just write integration of dA? That is 4 pi r square exactly. So this is Q, okay? In that case, this is Q by this epsilon naught. Understand? This is on the surface. Don't get confused, sir. You are writing Q in. This is on the surface over here, okay? Fine. Now, what will I exactly do? So can I just write this will be E is equal to this Q by epsilon naught, and this will be 4 pi r square. So it is nothing but 1 by 4 pi r square, 1 by 4 pi epsilon naught. It is something like that. This is the electric field formula, okay? 1 by 4 pi epsilon naught Q by r square. Understand? So this is basically the case over here. This is this r square. Remember, this is the capital R square, okay? This is the capital R square. This is the capital R. This is the capital R, okay? Because we are taking this R over here. Let's go for this one. Outside the point. Now, this is capital R. And at this point, we are supposed to find this is at r distance. In this case, r is greater than this r. Can you tell me? Can you tell me how much will be the electric field in this case? Okay. In this case, r is greater than this r. Tell me, it is exactly same, but you need to replace this r with that r. At this point, you need to basically exactly find this electric field, okay? Consider this as this surface, okay? As a Gaussian surface. So over here, I would say this is nothing but dA, and this is nothing but electric field E. E dot dA, E dot dA. Understand cos of theta, cos of 0 degrees. Over here, use the Gauss law. E dot this E dA cos of 0 degrees is equal to Q inside by, this is the Q inside right now, that is Q inside by epsilon naught. Understand? By using the Gauss law. In this case, can you tell me how much it will be? You'll simply say, so right now we are taking this as a Gaussian surface, okay? So in this case, can we say this is integration of E dot this dA is nothing but QIN by epsilon naught. Now, what we exactly need to basically put over here, that is this R, this R. So can I just write integration of this? If we add all of these dAs, we'll get the total surface area, that is 4 pi this small r square is equal to QIN by epsilon naught. So electric field will be nothing but Q. Simply I'll just write, okay, Q by 4 pi r square epsilon naught. It will be 1 by 4 pi epsilon naught Q by r square. See, it feels like, what was the electric field? Because of a charge, this is a charge. Because of this charge at this point, electric field will be KQ by r square. It is similarly like that. You can exactly behave, it will behave as a point charge at any point r distance. Electric field will be KQ by r square. Okay, fine. So now I'll tell you the variation over here. these are just the cases. That is why I am writing, okay, this R. See, in the third case, you basically mentioned this R. Understand? So if you basically mentioned this R only, so in this third case, you need to write 2R, or what is R dash. Understand? That's why in this case, we are putting this R at what distance from this one? At what distance from this one? That's why over here as well. That's why we are mentioning this is a case of when R is less than this one. That's why these are the cases. Case number 1, case number 2, case number 3. R is radius, okay? That's why are we writing? You got it now, what I am trying to say? Now you tell me how will be the exactly the curve in case of electric field variation with R in case of conducting these spheres. Understand, we call these conducting spheres because charge is present on the surface. So can I say it will be something like this? Initially the graph will be something like this. Initially the graph will be something like this, okay? Then it will be something like this. Then it will be something like the 100%. Now you will say, sir, how? See, when R is equal to 0, understand, means when R is equal to 0, when R is equal to 0, understand, in this case, understand, in this case, means you are talking about this point or inside point, means when R is equal to 0 or R is less than this R, inside point, understand? So in that case, can we say this electric field is basically 0? Over here, electric field is basically 0 inside point, understand? Now, the next point is when R is equal to this, when X is equal to R, when X is equal to R on the sphere, the electric field is maximum, understand? The electric field is maximum. And when you go away from the electric field, this electric field keeps on decreasing, this electric field keeps on decreasing, understand? Because we say if this is a charge, it is, you can understand it something like this. Near this charge, electric field is maximum. When you go away from this charge, electric field decreases with R. So electric field decreases with R when you go away from this charge. So at this point, electric field will be less. When you go till infinity, it will keep on decreasing. So this electric field variation is E is inversely proportional to R square. It is something like that. This is for the case number 1. This is for the case number 2, maximum electric field. This is for the case number 3, then it keeps on decreasing. Okay, this is the question. Next, I'll be showing you in the upcoming time because for that I have to teach you the dielectrics. Okay, before. Okay. Thank you so much, ladies and gentlemen. So this was all about today's lecture. And apart from this YouTube platform, we have this Unacademy's own platform where we basically teach. Country's top educators are teaching you over there. And over there, you can basically go for this plus subscription. You can go for this Iconic subscription, okay? And if you take this plus subscription, you'll be getting live classes every single day, weekly tests, structured courses, unlimited access. Understand this? And if you take this Iconic subscription, you will be getting the personal guidance and all the benefits you get in plus, test analysis, experts guidelines, study material, study planners, everything you're going to be getting over there. Yeah. Okay. We have almost covered the entire electric flux and Gauss law. And next we'll be talking about some capacitance and all. Let's see. Fine. And if you want to follow me, you can definitely follow me on Unacademy. This is my username over there. Yes. And see, guys, you should definitely go for this test. Understand? So, because if you are under 1000 rankers, in that case, you'll be getting the 100% scholarship in Unacademy. Okay. There are so many other benefits that you're gonna get in that case. And if you basically enroll in this one, you have to use my code. Okay. You can use my code. This is my code for enrolling this one. You can scan it over here as well for registration. There will be 90 questions 180 minutes. Okay, this is a JEE mains pattern. And these are the batches which have recently launched on Unacademy. This is the Shine batch. This is completely in English language. If you want to take it, you can definitely take it for now only. Now, this is, you can take this plus subscription for 12 months. You can take it for 18 months. You can take it for 24 months as well. You can take it for 24 months. Okay. By using my code, you can definitely get the maximum possible discount. This is my code. You can get the maximum possible discount by using this code only. Okay. Now, if you take this Iconic subscription for like 12 months, 18 months, 24 months, you'll be getting the maximum possible discount. Use my code in order to get that discount. This is my code. Okay. This is the pricing accordingly, and you can pay it monthly even. Okay. It'll be on 12th of September. Okay. Monthly. You can pay also because there are EMI options available as well. So there is so much big surprise coming up for you people if you join that. Now we have this beautiful feature on Unacademy, that's Ask a Doubt. I suggest you to basically have a look at this. Okay, if you have any sort of doubt, unlimited number of doubts. If you have the plus subscription, you can ask unlimited number of doubts. You can ask the doubt any damn time, get the high quality video solutions as well, and get the exact matches of the questions. Understand? Now, how you can exactly ask the doubt? You have to basically click on the solutions, okay? Doubts and solutions, then take a picture. Afterwards, the picture should be exactly, it should be clear, it should not be blurred or something. And you have to basically crop that particular question. You should not send so many questions at a particular time. You need to crop that question and post it on Unacademy. You'll definitely get the solution within no time. These are the rules and protocols that you need to follow while doing this process. Okay. Thank you so much, ladies and gentlemen. It was really nice interacting with you. I suggest you people to basically subscribe to this channel, hit the bell notification, and like this video and share this video before you leave. Thank you so much. See you guys tomorrow. Bye bye. Take care.